Look at the Earth from space. We named our planet after soil and ground, but from this height, it appears as a single blue shimmering sphere. This visualization shows the surface area breakdown. Water covers 71% of the globe, leaving just 29% as dry land, the green and brown patches we inhabit. Humans build civilizations on that small fraction of dry land, but every continent exists within a global system managed by the saltwater surrounding it. These dry areas are divided into 7 massive continents: Asia, Africa, North America, South America, Antarctica, Europe, and Australia. Surrounding them are 5 major oceans: the Pacific, Atlantic, Indian, Southern, and Arctic. Though labeled separately, they flow together as a single continuous body of water. Smaller sections of these oceans that are partially enclosed by land are called seas, such as the Arabian Sea, tucked between the Indian subcontinent and the Arabian Peninsula. Yet, on a planet covered in water, human communities worldwide face a persistent shortage of fresh water. This volumetric comparison shows why. 97% of Earth's water is salty. Once you subtract the fresh water frozen in glaciers or trapped deep underground, less than 1% remains on the surface for daily use. Because dark ocean water absorbs massive amounts of solar energy, it powers the global water cycle. As the surface warms, seawater evaporates into the air. High in the atmosphere, that vapor cools and condenses into massive cloud systems. Winds push these clouds over land, delivering rainfall thousands of miles from the coast. The summer monsoon rains that sustain agriculture across India are born from this oceanic evaporation. Without the ocean acting as a continuous rain engine, every continent would be an arid wasteland. Beneath the surface, the water is constantly moving. These currents act as a global conveyor belt, transporting warm tropical water toward the poles and cycling cold water back toward the equator. This circulation distributes heat around the globe, preventing extreme temperature shifts and keeping the continents habitable for plants, animals, and humans. This oceanic influence extends down to the microscopic scale, where the sunlit upper layers host organisms called phytoplankton. These tiny marine plants perform photosynthesis. In the process, they produce over half of the oxygen in Earth's atmosphere. Whether we live on a coast or deep inland, every second breath we take is manufactured by this marine flora. This energy transfer can also turn destructive. When abnormally warm ocean waters cause rapid evaporation, they create intense low-pressure zones in the atmosphere. Earth's rotation spins these systems into tropical cyclones. They bring torrential rains and push walls of water called storm surges onto land. In 2013, Cyclone Phelan drew its energy from the Bay of Bengal, forcing over 1 million people to evacuate. The ocean also sits on moving tectonic plates. Sudden underwater earthquakes or volcanic eruptions can displace millions of tons of seawater in an instant. This creates a tsunami. In deep water, these waves travel as fast as a commercial jet. As they hit the shallow coastal shelves, they slow down and compress, growing into cataclysmic walls of water. The 2004 Indian Ocean tsunami demonstrated this destructive power, striking 14 countries and causing massive loss of life across the region. To mitigate these risks, many countries now share data from early warning systems. Deep ocean sensors detect seismic anomalies and changes in water levels, allowing communities to react before the waves reach the shore. The same ocean energy that sustains global life is capable of erasing coastal infrastructure in hours. The relationship is constant. The salt water, covering 70% of the planet, determines the weather, oxygen levels, and economies of the 30% covered by land. But this life support system is currently degrading. Despite its immense power, the ocean's health is being undermined by human activity. Every year, millions of tons of plastic waste enter the sea, breaking into microplastics that choke marine ecosystems. Industrial pollutants, overfishing, and climate-driven ice melt are destabilizing the ocean's chemistry and biology. We cannot prevent a tsunami or a cyclone, but the degradation caused by pollution is a preventable choice. Geographical literacy shows us that the continents and oceans are a single, connected system. Protecting the ocean is the only way to safeguard human civilization on land.